Hello students, in this video we shall learn additional properties of alpha cuts in the form of theorems. The concept of alpha cuts and strong alpha cuts play a principal role in the relationship between fuzzy sets and crisp sets because we know that if A is a fuzzy set, then alpha cut of A will be a crisp set. And so the alpha cuts can be viewed as a bridge between the relationship between a fuzzy set and a crisp set. Now, before examining this connection, we first overview some additional properties of alpha cuts and strong alpha cuts. And all these properties involve the standard fuzzy set operation and the concept of subset of a fuzzy set. So let us see those properties in the form of theorem in this video and in our upcoming videos also. So let's begin with it. This is the first theorem that covers the elementary properties of alpha cuts and strong alpha cuts. This theorem states that let A, B be an element of the set of all fuzzy sets of the universal set X. So this notation represents all the set of all fuzzy sets under the universal set X. So we consider two sets out of all the fuzzy sets under the universal set X. And the first set that we consider is A and the other set is B. So we consider two fuzzy sets A and B. Then the following properties hold for all alpha, beta element of 0, 1. So let us see the properties. So these are the five elementary properties. Let us start to prove one by one. So the first property says that the strong alpha cut of a fuzzy set A is a subset of alpha cut set of a fuzzy set A. So let us prove this theorem now. So first we are going to prove that. To prove, that is, we are going to see the proof of the first subdivision. So what are we going to prove? We are going to prove that the strong alpha cut of the fuzzy set A is a subset of alpha cut set of A. Now in order to prove that one set is a subset of another set, in the concept of crisp sets, we have to choose an element in the strong alpha cut set, and then we have to prove that that element also belongs to the alpha cut set. That is, we have to prove. So to prove, if we consider an element X to be an element of strong alpha cut set, then it must imply that that element also belongs to the alpha cut set of the fuzzy set A. So this is what we have to prove. So let us see the proof of this now. Now what is an alpha cut set? By the definition, alpha cut set is equals to all those elements of the universal set such that the membership grade of that element will be greater than or equal to alpha. So this is an alpha cut set. And what is a strong alpha cut set? It is equal to all those elements of the universal set X whose membership grade is strictly greater than alpha. So this is alpha cut and this is strong alpha cut. Now we have to prove this. So to prove this, first we will consider that X is an element of the strong alpha cut set. And then we shall prove that it is also an element of the alpha cut set, and therefore this will become a subset of this set. So let us first consider X is an element of the strong alpha cut set. So let X be an element of strong alpha cut set. By the definition of the strong alpha cut set, if X is an element of this set, then what does it imply? It implies that the membership grade of X is strictly greater than alpha. Now, from this, we observe that for X to be an element of the alpha cut set, It has to be either greater or equal to. So this greater comes under the alpha cut set also. So this implies that x is also an element of the alpha cut set. This is trivially by the definition of alpha cut and strong alpha cut set. So therefore we started with an element x which was an element of the strong alpha cut set, and we have proved that it is also an element of the alpha cut set, which implies that the strong alpha cut, the strong alpha cut of A is a subset of the alpha cut set A. So this is the first proof of the first, this is the proof of the first property. Next we will prove the second property. That is, the property says that if alpha is lesser than or equal to beta, then it implies that the alpha cut set of the fuzzy set A contains the beta cut set of the fuzzy set B. Or we can also say that the beta cut of the fuzzy set A is a subset of the alpha cut of a fuzzy set A. Similarly, it also holds for the strong alpha cut. So we consider alpha to be lesser than or equal to beta. Then we have to prove these two. So first what we shall do, we shall consider alpha is lesser than or equal to beta, and we shall prove that the alpha cut set of A contains the beta cut set of A. So let us see the proof now. So the second subdivision is to prove, that is to prove. So what we have to prove is, if alpha is lesser than or equal to beta, it implies that the alpha cut set of A contains the beta cut set of A. So that is, we have to prove that if alpha is lesser than or equal to beta, we can rewrite this as beta cut of A is a subset of alpha cut of A. So this is what we have to prove. That is to prove that. So that is to prove that if we want to prove that this set is a subset of this set, we have to consider an element x element of the beta cut set A. So when we consider an element from this set, it should imply that x also belongs to the other set, that is the alpha cut set of A. So if we prove that, it is proved that this set is a subset of this set. So let us prove that now. Now by the definition, what is alpha cut set? It is equal to all those elements of the universal set such that the membership grade of X is greater than or equal to alpha. So similarly, what will be beta cut? It will be equal to all those elements of the universal set X such that the membership grade of those elements will be greater than or equal to beta. So this is alpha cut set and this is beta cut set. Now it is given that alpha is lesser than or equal to beta. Okay, so now we have to first consider that let X be an element of beta cut set A. So this implies that if X is an element of this set, then what is the condition we know? Or the membership grade of X will be greater than or equal to beta. But as per our assumption, what we have taken, beta is greater than or equal to alpha. So this is greater than or equal to alpha. So from this we can say that the membership grade of X is greater than or equal to beta and beta is greater than or equal to alpha, and so we can say that A of X is greater than or equal to alpha. So if A of X is greater than or equal to alpha, by this definition what do we know? That A of X is greater than or equal to alpha means X is an element of the alpha cut set. So this implies X is an element of the alpha cut set A. So we started with X an element of the beta cut set of A, and we proved that X also belongs to the alpha cut set of A. So this implies that the beta cut set of A is a subset of the alpha cut set of A. So that is what we have to prove. See here, beta cut of A is a subset of alpha cut of A, and hence we can say that the alpha cut of A contains the beta cut of A. So we have proved the second property also. Now the proof of the third property, fourth property and the fifth property we shall see in our next video. Thank you.